So here's the second video as we walk through the cross-validation process. We're going to look at two different things. All right, so we've created our sample and our training and validation, right? So training meaning based on the data, what can we learn using this algorithm? What pattern can we learn, right? So with this algorithm, what pattern can we extract from the data with these particular variables? So the first thing that we need to do is let's run a regression only on the training set. And so the way we do that, we'll go to data, select cases, and our condition is if sample equals 1. Okay. And so we essentially just selected, right? So we've got a filter turned on right here. And now when we run the regression, let's go analyze, regression, linear. When we run this, it's only going to be for the filter that we have in place. So let's click OK. And we see that our R squared looked like it went up a little bit. We can look here on our degrees of freedom. Okay, our coefficients have changed. And nothing too crazy here with our VIFs. Okay, looks like it deviated a little bit more, but it kind of came back to the line. We're hugging the line better here. And we can look at our pattern. So this is good and all. Now what we need to do, what's important for us are these coefficients. We're going to derive a predicted, so we're going to predict this line, right? We're going to predict our best fitting line or the predicted line with our current values, the current data that we have, and then we're going to apply it also on the 20% that hasn't seen this equation. And we're going to evaluate our predicted variables and see how well they're correlated. So let's go turn our data, all cases. We're going to turn the filter off now. Click OK. And now let's compute a variable. We'll call this predicted. Predicted y. And so we got our constant, which is 34620.628 plus our binary, right? The gender variable. And so that is 4208.877. Make sure you don't use any commas. We're going to multiply that times the coefficient plus 1063.458 times, that's years 1, so double click, plus 170.215. You can click it, or as long as you're typing it in correct, it'll still populate, right? So we got education 1, so minus 12988.989 times Just a few more words and we'll have it all wrapped up. If it makes you feel more comfortable, you can do that. You can put parentheses around these. So make sure you don't leave a gap on the minus like I did there. We'll want to make sure we close that up. And this will give us a predicted y. Okay, so let's click OK. And if we come over here, we now have values predicted. And we could test this as well, right? For test purposes, um, just to demonstrate. Let me bring it up for you. Okay. So, okay, here we go. Let's look here. For the first value, let's look at copy. I'm going to expedite this a little bit. Control V. Okay. We're interested in are the coefficients right here. By running our quick calculation, right? And so for the first one, let's go to output. Let me populate the Excel so you can see. Actually, I want, here we go. So for the first value, we've got constant or binary for gender is to 1. And then for years 1, we've got a 3. For years 2, we've got a 1. Education, this is for observation number 1. It looks like a 0. Okay, 0. They have education 3, and we've got a 0. Okay, and so if we were to equal that value, equal, and if I sum this equals sum for the predicted value, 33,628, 33,628, 44. Close enough. Okay. So that's how we are getting our predicted. And we're doing it also. This line's already been fitted, but the one it hasn't that we're going to test is the 20% validation. So once we've compiled that, what we need to do, okay, we're going to data and we'll split. Okay, we're going to compare groups and we're going to compare them based on the sample. Okay, click OK. And now let's go over to analyze, correlate, bivariate. And we want to evaluate the predicted Y. Two-tailed. Okay. And let's see here. We want to evaluate Okay, so this is predicted salary, this is actual salary. All right, okay, like that. Okay. So look what we've got going on, folks. This was our training. We got a correlation of the actual and predicted about 0.84. And then we go up here to the holdout, it drops to 0.64. This is smaller. We got 32 records. So this factors in, but I'll tell you, this is indicative of overfitting. So this training is suggestive of um, uh, over exaggerating, right? So the model based on this, and when we test it on the validation, we want to see them relatively the same. And that tells us that our model is the training and the validation. It's a stronger model. This says it overgeneralizes is the best way to say that. So we would need to collect more data. Okay. All right. So that's what's going on there. Another way that we could derive these values. So I showed you how to do it from the regression. So we got a predicted. How else can you do that? Pretty easy. We go over here we turn off the split or the split file. We want to analyze all. Okay. What we would do is